Hi students, welcome back to the channel. Today I am going to discuss about the important note on continuity and differentiability, chain rule, product rule, quotient rule, and some example on these rules. First one, what is an important note on continuity and differentiability is all the differentiable functions are continuous, but not all continuous functions are differentiable. Continuity implies a continuous unbroken graph, while differentiability requires a smooth graph without corners. A functions like continuous everywhere but not differentiable at due to the sharp corner. For example, look at the graph here. This f of x is equal to mod x graph is there. What is an output? Minus x if x is less than 0. It is a plus x if x is greater than 0. This is a graph of mod x. This is a continuous. It is a continuous graph. But this is a sharp curve is there. Sharpness is there. It is not differentiable at x is equal to 0. Still, I want to verify how it is not differentiable at x is equal to 0. Look at here, f of x, f dash of x. I will differentiate this one, that is a minus 1 if x is less than 0, because differentiation of x is 1. This is a minus x is there, minus 1. Differentiation of plus x, what is that? Plus 1 if x is greater than or equal to 0. Now, left hand derivative is not equal to right hand derivative. Therefore, left hand derivative is not equal to right hand derivative. Now we can give the conclusion is that modular function is not differentiable at x is equal to 0. Therefore, all the differentiable functions are continuous, but all the continuous are not differentiable. Okay, this is very important. Next, some basic formulas for the differentiation. First one is a power formula, that is an x power n. Differentiation of x power n is an n into x power n minus 1. And what is the differentiation of variable along with the constant? Ax differentiation. Now keep constant as it is. Differentiation of x is 1. X power 1 into x power 1 minus 1, that is a 1 into x power 0 is an 1. 1 into 1 is a 1, that is a into 1 is a. Okay, whenever the constant along with the variable, keep constant as it is, differentiate variable. Next, product rule. What is the differentiation of u into v? That is called product rule. Keep first function as it is, differentiate second function, plus keep second function as it is, differentiate first function. Okay, this is a product rule. What is the differentiation of constant alone? That is always 0. Along with the variable, constant keep as it is, differentiate the variable. If the constant alone, if you differentiate, that is equal to the 0. Next, quotient rule, u by v. Differentiation of u by v is equal to second function keep as it is, differentiate first function, minus keep first function as it is, differentiate second function. Be careful here, if we interchange in the product rule, it will not affect anything, but here if we differentiate second function first time is, it will be changes. That's what, be careful. First function we have to differentiate in the quotient rule, keep second function as it is, minus first function keep as it is, differentiate second function by square of the denominator second function, v square. That is called quotient rule. Then differentiation of u plus v is an differentiation of u plus differentiation of v, okay now, with respect to x. Now chain rule. What is a chain rule? For example, differentiation of something sine square x is there. First I will look this one as an x square, that is what is x square? 2x, 2 sine x. Okay now, again have to differentiate this sine x, that is a differentiation of sine x is cos x. Okay now, it means that first look at the as a x square, afterwards sine x is a separate function, that is called as a chain rule. Same way here, u power a is an a into u power a minus 1. Again u, differentiate u, du by dx. With respect to x we are doing, okay, that is called chain rule. Now differentiation of u minus v is du by dx minus dv by dx. These are some basic formulas. Next, differentiation of trigonometric functions. Okay, now first differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Next, differentiation of tan x is secant square x. Differentiation of cot x is minus cosecant square x. Next, differentiation of secant x is secant x into tan x. Then differentiation of cosecant x is minus cosecant x into cot x. Be careful which are the negative it will come: cos x, cot x and cosecant x. Okay. Now first example. What is the first example? Find the derivative of the secant into tan of root x. What is the differentiation with respect to x? Now I will take a function here. What is an secant of tan root x? Now I am going to apply here chain rule. First I will differentiation of secant x. What is the differentiation of secant x? Now only we saw the formula secant x into tan x. Here tan root x as an x here. Differentiation of secant x is secant tan root x, tan of tan root x. Okay. Okay. Differentiation of this function d by dx of tan root x. Next step is that I wrote the first two terms as it is. Again differentiation of tan x is secant square x. This as an x as it is. The differentiation of tan root x is a secant square root x. Again this how to differentiate, differentiation of root x. Again this term as it is, that is an secant of tan root x, tan of tan root x. This is a secant square root x. This is a differentiation of root x is an 1 by 2 root x. Okay, now you can think as an x power 1 by 2. Apply the differentiation of x power n formula what we previously discussed. Okay, then final answer is differentiation of secant of tan root x is secant of tan root x, tan of tan root x into secant square root x by 2 root x. This is a final answer. Next, second one. Find the derivative of cos x cube into sin square x power 5 with respect to x. Now I took as an given value as an y, function y. Next, here product rule. This take as an u, that is an cos x cube. This take as an v, that is a sin square x power 5. Next, what is the product rule? We know that product rule u into v, the u dash into v, differentiation of first function into v, and plus u keep as it is, keep first function as it is, differentiation of second function. In the same way, first I am taking as an u as a this one, differentiate that one, u dash, that is an differentiation of cos x cube is a minus sin x cube. Again I have to differentiate this x cube, that is a 3x square. Okay, now final, that is a minus 3x square into sin x cube. Next v, this v, first this as an x square, like as an x square, that is a 2 sin x power 5, that is differentiation of sin square x power 5 is an 2 sin x power 5. Again differentiation of this sin x power 5 is an cos x power 5. Again this x power 5 differentiation is an 5x power 4, that is a 5 to the 10, that is a 10x power 4, then sin x power 5 into cos x power 5. Okay, this is a v dash. Now I am going to apply the product rule here. What is the product rule here? U dash, that is a differentiation of first function, u dash into v as it is, the v is as it is, then u as it is, that is a cos x power 3 is an as it is, into differentiation of v, the v I wrote here, this is the total v. Okay, now if I simplify, final conclusion is that 10x power 4 sin x power 5 cos x power 5, then cos x cube minus, this is minus 3x square sin x power 3 into sin square x power 5. Okay na? Thank you so much. Bye. Take care. In the next video we are going to learn about the composite function, inverse trigonometric function. Thank you so much. Bye. Take care.